Hello, this is Thomas Cobbs Jr. here with California Baptist University, Advanced Exercise Physiology, here to present my Cap 1 of ATP pathways. ATP stands for adenosine triphosphate. It has one adenosine molecule, one ribosome, and 3 phosphates. ATP is stored in our muscles and is a limited currency of energy. ATP is always being formed and broken down and is needed for growth and health of all life. Without ATP, cell transfer from location to location would not be possible. Next, the process of glucose and ATP. Starting at the top, we have our glucose molecule, which has 6 carbons. We get this from our carbohydrates, our proteins, and our fats. The first step, glucose goes through a process called glycolysis. To do this, we need to 2 ATP is taken, and through that 2 pyruvate is the byproduct. This is all happening in the cytoplasm. Afterwards, we move into the mitochondrion, where 2 acetyl CoA is created, giving us 2 CO2, which is then taken over to the citric acid cycle. In the citric acid cycle, we have 2 more ATP and 4 CO2. Next is the electron transport chain, where 2 NADH, 2 NADH, 6 NADH, and 2 FADH are used and move through, which create 4 to 6 ATP, 6 ATP, 16 ATP, and 4 ATP. Also, through this, we need to be able to transfer the oxygen over into water, or H2O, 6H2O. Through this whole process, the subtotal of the 4 ATP from these 2 are then produced into 36 to 38 ATP through the electron transport chain, which is then subtotal of 32 to 34. We get this number from the 2 ATP that we lost at the beginning. Next is fat and ATP. So we'll be discussing the B oxidation, which occurs 7 times. First, we have a pilometric acid, which takes 2 ATP away, which is then produces acetyl CoA. Through this, we have the first stage of dehydrogenation, utilizing FAD, which then gives us a byproduct of FADH2, which then gives us trans-anenyl CoA. The second stage is hydration, which gives us a product of hydroxyacetyl, which is then gone through the third stage of dehydrogenation once more, which gives us a byproduct of NADH. Next, this gives us ketoacetyl CoA, which splits off into 2 separate products, mistral CoA, or CH14, and acetyl CoA. At the conclusion of the 7th cycle, we're left with 3 products, 8 acetyl, 7 NADH, and 7 FADH2. 8 acetyl then binds to 8 oxaloacetic acid, which is then used for the citric acid cycle or the Krebs cycle. Next, 7 NADH and 7 FADH come together, which gives us the electron transport chain, which is later oxidized to create ATP. Next is the total yield of ATP. On the left, we have glucose, which has 2 ATP, 10 NADH, 2 FADH2, 2 GTP, which gives us a total of 32 ATP. On the right, we have fat, which has a 8 acetyl CoA, 7 NADH, 7 FADH2. We also need to subtract 2 ATP, which is the activation of fatty acid. This gives us a total of 106 ATP, which is significantly higher from the glucose ATP. The interaction across exercise. This will vary on intensity of the exercise. Glucose is 90 seconds of work during exercise. Best used for short max efforts. It can be used without oxygen and is a result of lactic acid. Glucose gives fuel for hours when used aerobically. Fat, fuel source for aerobic work, is the main fuel source during long, intense exercise, which drains muscle glycogen. Fat drains muscle glycogen and blood glucose. Fat also takes longer to reduce ATP. The limitations of ATP pathways for aerobic respiration is limited by oxygen consumption and is drastically decreased when exercise intensity increases. For example, it could be depleted during the warm-up may not be that high of depletion, but as the exercise increases in intensity, it will be depleted. Anaerobic respiration, the production of lactic acid makes it difficult for exercise. The more lactic acid, the lower the athletic performance. In conclusion, our nutrition choices using macronutrients, our protein, carbohydrates, and fats will depend on the exercise intensity. If you have an athlete who has a longer duration, fat intake will be best for that, just because fat is broken down slower. For short duration and power exercises, ATP produced from glucose will be most beneficial. Just speaking from personal experience, me as a personal trainer, I make sure I educate my clients the importance of proper nutrition pre-exercise, because not eating does not provide energy. I want to make sure they have the necessary fuel for that workout. Here are my references. Thank you very much. This has been Thomas Cobbs for my Cap 1 ATP Pathways. Thank you.